Hello, please check your answers to the problems on the Try These from the book. I'll give you a moment to look them over, and I'll click back. Now, if these weren't what you're getting, especially part D here, then please stick around and we'll go over them, work them out together. Some of them had extra steps. If all of these were perfect for you, including page 68, number 5, then please move on to the next slide. All about finding missing exponents. So if you're still here, I assume you're eager to find out what the issue might have been. On Try These B, where they wanted us to break the logarithm up, which does actually make it easier to evaluate when we have to. We don't have any outside multiplier, just the log of the stuff in the parentheses. And within the parentheses, everything is being multiplied. And if you were putting numbers in for the x and the y, the last thing you do is multiply 5 times x times y to the third. So this is basically multiplying, and to accomplish multiplying, we add these exponents. And these are exponents because they're logs. So we're going to rewrite this as the log of 5 plus the log of x plus the log of y to the third. And by adding these exponents, we are accomplishing this multiplication. Now the y to the third, though, is not quite done because this is y raised to a power, and then we're taking a power of the power. Powers of powers, we can do that with multiplication. So the first one stays the same, the second one stays the same. They're all base 10 here, but this one we will rewrite as multiplication. Multiplying the exponents will do powers of powers for us. And it's now just plus 3 log y. On part B, this is essentially a division problem. If you had values for x, y, and z, you would multiply these, you would raise this one to the 4th power, and then the last thing you would do is divide. So if you're dividing, you can accomplish that by subtracting the exponents. So we are going to subtract the numerator part minus the denominator part. Subtracting that takes care of the division, because these guys are exponents, base on base e. Now within this first term, we have multiplication, and we can accomplish that multiplication by adding the separate exponents. So we're going to make it the ln of x plus the ln of y. And within this term, we have a power of something raised to a power. So that can be redone as a multiplication. Takes some getting used to. Okay, they got bigger as they went down the page here. Essentially, just as we did in part B, this is a division problem. If you knew what number to put in for x, the last operation you would perform is division. So when we're pulling it apart, we're going to undo the division. We're going to rewrite this division as a subtraction, because when you're dealing with logarithms, you're dealing with exponents, we can divide, if we have the same base, by subtracting the exponents. So we'll keep the same base, the ln of x, minus the ln of the square root of x squared plus 1. Well, this one's pretty normal, but this one is actually a power in disguise. The square root, as you remember, that's a radical, and it can be expressed with a fractional exponent. So this is going to be the ln of x squared plus 1 whole thing raised to the 1/2 power. So now we have a power, because ln is an exponent, base e, multiplied of something that is already being raised to a power. And a power of a power, we're going to rewrite as multiplication. Put the 1/2 out front, ln of x squared plus 1. This will not break up further. If it was multiplication, we could rewrite it as adding the exponents. But this is going to stay just the way it is. Oh my, this one was the one that has this big, huge, long answer up here. Well, basically it's a square root problem. The last thing we would do is the square root. So we're going to rewrite that as we did over here as this whole thingy, 2x times the quantity x squared plus 2 raised to the 1/2 power. Now because the entire thing here is being raised to the 1/2 power, we can say that we're taking a power of all of this to the 1/2 power. And we can accomplish that by multiplying the exponents. So we're going to take 1/2 times log base 2 of this thing. But we have a multiplication in here. We're multiplying 2 times this parentheses. We can accomplish that multiplication by adding the logarithms. So we still have 1/2, and that's going to be times log base 2 on the 2x plus log base 2 on the x squared plus 2. All of that was raised to the 1/2 power, so all of that's got to be in there. Okay, it's getting spread out. Well, now let's see. We can not go much further with that, but this is a multiplication right here, that 2 times x. So it will break up further. So we'll have 1/2 times log base 2 on 2 plus log base 2 on the x plus log base 2 on the x squared plus 1, plus 2, sorry. Whoa. Now there's a crazy thing happening here. Right here. This is its own little beastie. We have log base 2 of 2. Now if we rewrite that in exponential form, this says 2 to the x equals 2. And x is going to equal 1. Because we're asking what power do you put on 2 to get 2? And that would be the first power. So now we have 1/2. This thing here equals just the number 1. Because we have a base 2 and the answer was 2, the exponent must have been a 1. Plus log base 2 on x plus log base 2 on quantity x squared plus 2. Now what they did to get their answer was they distributed, which we don't usually do. We usually just leave the 1/2 out there. But they distributed it and multiplied everybody in here by 1/2. And that's how they got their answer. On the next section, they wanted us in try these C to put them back together, which for some people is harder to do. So we usually take care of the multiplication first. It's usually the last thing we do when we're ripping them apart. It's one of the first things we can take care of when we're putting them back together. So we can make this, since we can't simplify within this parentheses, this is just a subtraction here. Now it doesn't say that the whole thing is getting multiplied by 3. Like down here, the whole thing is getting multiplied by 1/2. This is only 3 times the ln of x to the -1, to the -1. So we can rewrite this as the ln of x minus 1 to the third minus the ln of x. Because if we're multiplying exponents, we are really taking a power of a power. And then this just becomes a subtraction. We're subtracting this exponent minus that exponent, means that what was originally happening was that this was a division problem. Original division problem was rewritten as subtracting the exponents. So this would be x minus 1 to the third divided by the ln of x. This one's not the same. It will be eventually, but not right now. Right now we have log x minus 4 times this entire sum. So we can distribute this. We can make this log x minus 4 log x minus 2 minus 4 log x plus 2. Oh my. So we would have log base x minus the log of x minus 2 to the fourth minus the log of x plus 2 to the fourth, because when we're multiplying the exponents, they are really powers. Wonderful. So now we have a subdivision. We're subtracting logarithms, so this would really be a division problem. And we could write that as log base 10 of x divided by x minus 2 to the fourth times x plus 2 to the fourth, because we are dividing by both of those. We could have left it like that, because both of these are raised to the fourth power. We could make this x minus 2 times x plus 2 to the fourth. But x plus 2 times x minus 2, that's easy to multiply out. You remember all the sum and difference of logs. Sum and difference of perfect squares that we did. So this they wrote as x minus 4 to the fourth. Now I have to be honest with you. We could have done this differently. We could have raised this whole thing to the fourth power, written the division, multiplied these out, and then applied the fourth power. It might have been shorter by one step. So maybe we could do that to this one. Maybe not. We could distribute it, but I think this one's going to be shorter if we do what's inside the brackets first. Leave the 1/2 sitting there. Take care of what's inside the brackets, which we could have done in the last one. We could have taken care of what was inside the brackets first. We're subtracting logarithms. That means we're subtracting exponents, which means this was originally the ln of a division problem of x plus 2 divided by x squared minus 4. And now we could put this together. The 1/2 times the log means we are multiplying exponents. That's going to rewrite as the ln of all of this thing to the 1/2 power. Now we could take the 1/2 power of the numerator over the 1/2 power of the denominator. This, I didn't get the same answer as they did in the book because I reduced this. Now that may leave out one of the original parts because it will cancel out. That might be why they did not reduce it any further. They could have left it like this. They chose to write it as a square root because that's what the 1/2 power means. But I still believe that some textbooks would factor this as x plus 2 times x minus 2 and cancel out the x plus 2's. But we would not come back then to this original problem if we did. If we tried to take this answer, check it by working backwards, what we have right now would come back to this. If we can't reduce this fraction here and canceled out the x plus 2, made it 1 over x minus 2, we would not be able to come back to the original answer. Okay, part B. want us to know what the issue was with this. Well, you may have noticed that this is log x plus 5, this is log x plus 2, but this is 2 to some power. This is 5 to some power. And just like with exponents, none of these gimmicks for dividing by subtracting the exponents, multiplying by adding these exponents, none of these gimmicks work if they're not the same base. So we can't do anything more with this because they are not the same base. And because they're not the same base, we can't combine them. If they were both either base 2 or base 5, we'd be good. Okay, on page 68, number 5, some folks might have been surprised that the answer to this problem was simply 2. Okay, this wanted us to paste it together as a single logarithm. It wanted us to combine it. Well, we can do that. We can either, because we are adding here, we can either rewrite this addition of exponents as a multiplication, or we can treat the 2 times the log of 2, the fact that we were multiplying means we're taking a power of a power. Whichever one, we could do either one first. I'm going to go with writing it as multiplication. This would be the log of 25 times that won't work, will it? That won't work. I messed up. I can't combine them with the 2 sitting out there. Got to get rid of that 2 first. So we'll keep log, base 10's understood, of 25. And because we are multiplying the exponents, this is going to become a power of a power. This would be log of 2 raised to the second power. Well, we can do 2 to the second power. So 2 to the second power, that's going to be log of 4. Okay, now we're adding exponents. So now we can go ahead and write it just as a multiplication. If you're adding exponents, what you're really doing is multiplying. So this would be one single log of 25 times 4. Now they would expect us to multiply that. This would be the log of 100. Now that's as simple as the log expression gets. But remember, this is really log base 10 of 100. And we can do that. We can come up with that number. This says what power on 10 equals 100. And that, of course, is 2. So this says 10 to the some power came out to 100. And that power would have to be just 2. So we'll keep working on these. If I can get this to stop. And please move on to the next slide where we will explore finding a missing